So the homework was like this. Suppose you got a switch and then you got some computers here, and if I'm not wrong it is VLAN 20. Okay, yeah, VLAN 100. Okay, cool. So this is VLAN 100 and this is VLAN 300 and this is VLAN 200. Okay, and this I suppose VLAN 1. If I'm not wrong it is VLAN 1. Okay, so these machines will communicate with each other. These machines will communicate with each other. Again, these machines will communicate with each other, and these also will communicate with each other. Okay, now, so from one VLAN to another VLAN, you will not have any communication. Okay, so this is the conclusion. Now, let me tell you, now let me teach the next thing here. Switch interface modes. So you can write the heading, switch interface modes. Switch interface modes. Okay, now the first mode is called access mode. Access mode. The second mode, it is called trunk mode. And the third one is called dynamic mode. So you got three modes here: access, trunk and dynamic. If you tell, or say if you ask me what is access, I'll tell you, if you make the interface participate in access mode, then it will be part of a single VLAN, or it will participate in a single VLAN. Yesterday you have given the command switch port mode access. Okay, so yesterday I told you that, say, to assign a an interface to a VLAN, first you will give switch port mode access. That means you are assigning it as access mode, and that means when you assign it as access mode, it will participate only in a single VLAN. And which is that VLAN here? In here it is VLAN 100, and here it is VLAN 200, here it is VLAN 300, and here it is VLAN 1. So that means it will participate in a single VLAN, or it will pass that VLAN information in which it participates. Clear? Fine? Okay, now, so here access mode. Now if you have a connection like this, suppose you got a switch, you got another switch here. Okay, now we have, say, suppose this is our diagram. Say suppose here we got two machines. This is VLAN 100 and suppose this is VLAN 1 machines. This is VLAN 1 and this is VLAN 300 machines, V300. The same here. VLAN 100, VLAN 1, VLAN 300. Okay, so now the same VLANs will communicate. That means the VLAN 1 to 1 will communicate, VLAN 100 to 100 will communicate, and VLAN 300 to 300 will communicate. The same here as well. Say VLAN 100 will communicate, 1 to 1 will communicate, 300 to 300 will communicate. Now if at all we want them to communicate, if at all we want this VLAN 100 to communicate to this VLAN 100, then we'll have to connect between these switches. Obviously we need to connect between the switches. So you will connect switch 1 and switch 2 here. Switch 1 and switch 2. Now when you connect it, suppose using F0/24 and F0/24 here. Okay, now say VLAN 1 to VLAN 1 communication will happen, but VLAN 100 to 100 will not happen, because yesterday I told you by default all the interface participate in which VLAN? VLAN 1. Okay, all the VLAN will participate in VLAN 1 by default. So whenever this VLAN 1 machine is sending something, it will be sent to here. It will be, suppose it's a broadcast, it will be sent to the interfaces participating in VLAN 1. It will be sent to all the interfaces participating in VLAN 1, including this interface, which is also participating in VLAN 1. So he will be sending it to here, and switch 2 will send it, and switch 2 will receive it, and switch 2 will forward it to all the VLAN in 1 interfaces. Clear? Now, what if you need this VLAN 100 to communicate to this VLAN 100? Then you will have to make this F0/24 and this F0/24 participate in VLAN 100. Get it, guys? Okay, so if you make this as VLAN 100, what happens is that these machines, when this machine is sending a broadcast, it will be sent to all the interface participating in VLAN 100, including this machine. Then the switch 2 will receive it, the switch 2 will forward it to all the interfaces participating in VLAN 100. At that time, VLAN 1 will not be able to communicate with each other, because the link which is connected is participating in VLAN 100 and it does not send the VLAN 1 traffic. Clear? So now, what if you want VLAN 1 to communicate with each other? Any idea? We didn't come to that, right? So if at all VLAN 1 needs to communicate with each other, we'll have to give another line, right? We'll have to give another line, or we'll have to give another cable, suppose F0/23 and F0/23, and by default it participates in VLAN 1. Okay, it is as if, say, suppose you got, say, let me just tell you, we got men here, men, and we got women here, and we got children. The same, men, say women and children. Now there is a line, and this line says only men can pass through this line, or it is the line for only men. Then only men will be able to pass from this location to this location. Only when men will be able to pass, right? Now what about, say, then what if women want to travel from this location to this location? You will have to, yes, keep another path for women, right? For children also we need to keep another path here. Separate individual paths needs to be given. The same concept here. So if you have VLAN 100, then you will give, or you will have a VLAN 100 here, or if at all you want to send VLAN 100 information, you can make these interface participate in VLAN 100. Then if you have VLAN 1 information, you need to have another interface and you need to give VLAN 1 here. Now if you want VLAN 300 to participate, then say VLAN 300, you need to give another path where VLAN 300 can be passed, or where VLAN 300, where those interface participate in VLAN 300. So if you have, say here you have 3 VLANs and you need 3 connections here, right? So if you have 10 VLANs, you will need 10 connections. Now if you have 20 VLANs, you need 20 connections. That will make it complicated, right? Or to make it easier, what I'm gonna tell is that, suppose here it's a location, here it is another location. Say rather than, say, keeping separate individual path for women, men and children, I'm just keeping a public road here, right? Or just a path will be there and the path says everyone can travel. Everyone in the sense, men can travel in this path, women can travel in this path, and also children also can travel in this path. So similarly you can give, say, F0/24 here and another F0/24, and you can make them participate in another mode that is called trunk mode. What is it? Trunk mode. So if you make them participate in trunk mode, then the trunk mode is similar to the public road, or it is, say, it will pass all the VLAN information. Okay, so here it will pass the VLAN 100 information, it will pass VLAN 1 information, and it will pass VLAN 300 information also. Clear? Fine? Okay. Now, so to make it as a trunk link, we'll go to that interface and we'll mention the command switch port. Yesterday, to make it as access, I told you the command was, say, we'll go to that interface and we'll mention switch port mode. No,
Mode
switch.
access.
Yes, switch port mode access. That was the command. Then we have mentioned the VLAN, switch port VLAN or switch port access VLAN, whatever with the VLAN is, we'll mention that. So that was the command. And to make it as access, this is the command, switch port mode access. Okay. Similarly, to make the interface as trunk port, you will mention switch port mode trunk is the command. Switch port mode trunk. That particular interface. We'll go to that particular interface and then we'll mention switch port mode trunk. Clear? Okay, so now let me tell you this. So this is the, say this was the yesterday's topology, right? So now let me just give you a task, the same topology. Okay, so this switch S1, say there you guys are having, say VLAN 300 machines. Okay, you're having VLAN 200 machines. You are having VLAN 100 machines, and we are having VLAN 1 machines also. Okay, now the same thing, you will take another switch here and implement the same thing. Okay, say switch 2, you will have 2 machines participating in VLAN, say 300. Then 2 machines participating in VLAN 200. Then 2 machines participating in VLAN 100. And 2 machines participating in VLAN 1. Okay, and you can have, so guys, I'll give you time to draw. Okay, so first let me explain this and then you will connect it. Suppose f0/20 and f0/20 you will connect. Okay, and after connecting it, now let me tell you, so what you're going to do is, here you will make that participate in VLAN by default. Okay, by default check whether VLAN 1 to VLAN 1 communication is happening or not. Okay, then the others, so then the others in the sense VLAN 100 to 100 will not communicate, VLAN 200 to 200 will not communicate, VLAN 300 to 300 also will not communicate. Only VLAN 1 to 1 communication will be there, because these interfaces by default participate in VLAN 1. Okay, then make this interface participate in VLAN 100. At that time VLAN 1 will not communicate, VLAN 200 will not communicate, VLAN 300 will not communicate. Okay, now after that make those interfaces participate in VLAN say 200. Okay, then at that time VLAN 1 will not communicate, 100 will not communicate, and 300 will not communicate. The same thing then at last, say VLAN 300 you will make it as VLAN 300. These interface you will make them as VLAN 300. Then check only, say VLAN 300 is communicating from the switch 1 to switch 2. Whereas the other VLANs, VLAN 200, VLAN 100, VLAN 100, VLAN 1 will not communicate. Okay, then the final thing what we will do is that make it as a trunk. Make it as a trunk. and after making as a trunk, VLAN 1, VLAN 100, VLAN 200 and VLAN 300, everyone will communicate to each other. That means VLAN 1 to 1 communication will be there, 100 to 100, 200 to 200, 300 to 300 communication will be there. Can you do it? Any doubts in this question? Srikanth? Fine. Kevin? Yesterday you didn't come, but you need to watch the... Yes. Okay, there. Okay, yes. Now, so that is the trunk mode. And now let me show you the trunk here.
Sir.
Yes.
Sir, open the packet tracer.
Sorry?
What I'm saying, open the packet tracer and connect the topology, and we will try to configure it by telling you.
Okay, sure. No issues. If you have any doubts, please ping me. Okay. But the problem is that if at all I'm sleeping or if at all I'm say busy, I'll not be replying. Okay. Now, so S1, suppose it is S2. Okay. Now, so here, suppose we are connected, say this one, F0/20 and 20. Okay, so let me connect 20 and 20. 20 and this 20. Okay. Now what I'm going to do is I'm going to make it as trunk. So let me create some VLANs here. So here, how many VLANs you got? VLAN 1 is already there, VLAN 100, VLAN 200 and VLAN 300. So let me create those VLANs. VLAN 100, VLAN 200, VLAN 300 and exit. Now the same thing we will create it here also. VLAN 100, VLAN 200, VLAN 300. Okay. Now let me tell you here, if you make this, if you connect this F0/20 and 20, I told you it will participate in VLAN 1, right? By default it will participate in VLAN 1. So show VLAN brief will show you, so F0/20 in VLAN 1 here. In VLAN 1 you can see F0/20. Now that I'll make this as trunk, we'll go to interface FA0/20. We'll give the command. What is the command? Switch port mode trunk. Switch port mode trunk. This is the command. Now let me ask you. Say previously for access mode the command was like this: switch port mode access. Then we have mentioned switch port access VLAN, then suppose 100 or 200, whichever you want, you will mention it. Do we need to mention it like here also? After switch port mode trunk, do we need to mention switch port mode or switch port trunk VLAN 100? Do we need to mention like that?
So by default, trunk will support all the VLANs.
Okay.
But if I want to restrict some VLAN, so we can exclude that VLAN from the trunk.
Okay, but my question was something like this: can you give it like this, or do you need to give it like this? Yes or no? Of course, I got answer from you. What about
No.
yes or no?
No.
No. You don't need to give it like this, and if you give it, then that is wrong. Let me tell you why. So previously for switch port mode access, you can mention like that, because I told you access mode will participate only in a single VLAN. So which VLAN it needs to participate, you are mentioning that only. Okay, if you mention switch port access VLAN 100, that means it needs to participate only in VLAN 100. By default it will be participating in VLAN 1, and then when you give this command, then it will participate only in VLAN 100. Now after giving switch port mode trunk here, Okay, it participates in all the VLAN. I told you it will pass VLAN 1 information, VLAN 100 information, VLAN 200 information, VLAN 300. It will pass all the VLAN information. So you don't have to specify this command, switch port, trunk, VLAN. You don't need to specify, because by default it will pass all the VLAN information. Clear? So now let me show it to you. So here, switch port mode, trunk. Okay, now one more thing here. In the real switches, when you do, you will have to give one more command. Before giving this command, you need to give one more command. So the command here which needed to be given is switch port trunk encapsulation .1q, which I'll tell you later what it is and all. I'll tell you later. In the real switches, or when you are doing it in the GNS3, you need to mention this one, switch port trunk encapsulation .1q. You need to mention it. Then say, which will not, this command will not work in the packet tracer. Just understand there is a command like this. Then you will give the command switch port mode trunk. Clear? Now when you mention switch port mode trunk, it will pass all the VLAN information. So let me show you. Do so VLAN brief. Can you see F0/20 here? Anyone saw F0/20? No, because say here it has now disappeared from this show VLAN brief, because here it won't show the trunk interfaces. Here you can see after 19 you have 21 only, and you have 22 and all. So you do not have 20. So to see the trunk interface, you got a separate command, and that command is do show interfaces trunk. Do show interfaces trunk is the command to view the trunk interface. So when you check this, you can see F0/20 has become trunk here. Okay, and the mode is on. It is on mode, and you can see say VLANs allowed on the trunk, VLANs allowed and active in the management domain. You can see VLAN 100, 200, 300 are allowed in this trunk. That means it will pass the VLAN 1 information, it will pass the VLAN 100 information, it will pass the VLAN 200 information, and it will pass VLAN 300 information. Clear? So this is how you will see the trunk interfaces. Okay, now so I told you it will pass all the VLAN information. The trunk interface will pass all the VLAN information. Now you can customize the trunk. You can customize the trunk. If you do not want this VLAN 100 to be sent through this trunk link, you can remove the VLAN 100. You can do what? You can remove the VLAN 100. To remove the VLAN 100, what you're going to do is you'll go into the trunk interface. Okay, suppose interface fastnet 0/20. We'll go to that trunk interface. Then we'll mention the command like this: switch port trunk allowed VLAN remove 100. This is the command. Switch port trunk allowed VLAN remove 100. So you got an allowed VLAN list. This is the allowed VLAN list. From the allowed VLAN list, you are removing VLAN 100. Okay, then when you check it, you can see do show interfaces trunk. You can see VLANs allowed on the trunk, those are 1 to 99 and 101 to 1005. So where has 100 gone? 100 is not allowed here, so you cannot see 100. So even moreover, this also you can see, say they have removed VLAN 100 here. Okay, so that means 100 is being removed, and VLAN 100 information will not be passed through this trunk link. Any doubts? If you want to add it back, the command is simple. You will go to that same like that interface, that trunk interface, and instead of remove, you will add the keyword add 100. So switch port trunk allowed VLAN add 100. Then what happens is that do show interfaces trunk, you can see the 100 has come back. It will now allow VLAN 100 information. Clear? So this is how you will customize the trunk interfaces. Any doubt? Clear? Fine. Now, so this is the trunk interface. Now the next you got one more mode here, which is called dynamic mode. So dynamic mode, it will say if it's dynamic, then we'll change it to either access or trunk. It'll change it to either access or trunk. So that depends upon the situation. Okay, now that
We have to activate command on both of switches.
nope, I'll tell you. If it's dynamic, okay,
In turn mode.
sorry,
In turn mode.
I'll tell you. Okay, so here I've configured this interface as the trunk. S1's F0/20 I've configured it as a trunk. Say because here I'm say implemented the command, where is it? Switch port mode trunk here. Okay, now did I do anything in switch 2? No, I didn't do anything in switch 2, and say you can see it. Okay, I just created VLAN 10, say 100, 200 and 300, that's it. Okay, so what happens is that, say if I create a trunk here, and if this is dynamic, it will automatically change to trunk. We don't have to configure anything, it will automatically change to trunk. Now if you configure access here, and if it is dynamic, then it will also become, or it will automatically become access. Clear? But if you create access here and mention VLAN 10, it won't become VLAN 10 here. That you need to do manually. Getting it? Yes or no? One more time. Okay, got it? Okay, so everyone,
No, I don't.
one thing, I've given access, and after given access I'll tell switch port access VLAN 10. That means it is access mode. That means it should participate only in a single VLAN. And which is that VLAN? VLAN 10. Okay, now so here you are given switch port mode access, and then made it participate in VLAN 10. So if it is dynamic, of course it will move to access, but it will be in VLAN 1 only.
We have to.
You have to manually change it to VLAN 10. Okay. Now, so let me show it to you. So previously this was, say I made this as trunk, and this was dynamic, and it will automatically become trunk. Shall I show it to you? Okay, so let me again show this one, S1 here. S1 here, yes, you can see this. Show interface as trunk here. Do show interface as trunk. You can see F0/20 is trunk, and the mode is on. On means we have manually turned the trunking on. We have manually made this interface as trunk. Now,
So can you change the host name, please?
sorry,
Can you change the host name, please?
host. Sorry, I didn't.
Switch number.
Yeah, host name. Okay, sure, no issues. So suppose host name, this is S1. Okay, now this is S2. Host name is S2. Okay, now when you check S1, we have manually made S1 as the trunk. So do show interfaces trunk. You can see S1 here, the say F0/20 is trunk, and on, the mode is on. On means we have manually made this trunk. Got it? Now when you check S2, do show interfaces trunk. We haven't configured any interface in trunk in the S2. So when you give S2 as say this command, you can see F0/20 here automatically became trunk. How did it automatically become trunk? Because it was dynamic mode here, and the dynamic mode will automatically change it to trunk or access based upon the other end. Clear? There. Okay, so I suppose you have understood, right? So here the mode is auto. It will automatically become trunk. Okay, let me show one more thing to you.
Sir, before giving the trunk command in S1, when we connected the two ports, F0/20 and F0/20 are both the switches.
Mm.
So what will be the by default mode?
By default, it will be in VLAN 1. It will be in, say, I'll show it to you. Okay, if at all you connect two switches, suppose this is S3, and this is S4. Now, if you connect F0/20 and 20 and 20 here, okay. Now, say these interfaces will be, say by default, it will be in dynamic mode. Okay, let me show it to you. The command is, we'll go to, so let me change the host names. Host name S3, and here the host name is S4. Now, if you check a command, show interface fast internet 0/20 status. Okay, sorry, not status, guys. So switch port. Okay, interface fast internet, say switch port. So this command you can see F0/20. Okay, administrative mode is dynamic auto. That means it is by default administered or configured in dynamic auto. It is dynamic. Okay, by default it is dynamic, but operating in static. Access, or you can say operating in access mode. So if you don't do anything, then it will be access mode here. Here also it is access mode, because by default it is dynamic. Okay, here also it is dynamic, and here
That means VLAN 1 is passing, right?
yes, of course. Okay,
Whatever the ports are in there in VLAN, that VLAN 1 information only goes.
yes. So if it is access, then by default it will pass only VLAN 1. By default it will pass VLAN 1 information. The same here, access, and by default it will pass VLAN 1 information. So let me show it to you. Do show or show interfaces trunk. Sorry, show, say VLAN brief. You can see F0/20 is here. That means if it is access, by default it will pass VLAN 1 information. Clear? Now coming back to our topology, previous one. Now S1. So here what I did was I made this as trunk. And I made this manually as trunk. Here I didn't configure anything. So if it is dynamic, it will move itself to trunk. Automatically it will move itself to trunk. Let me show it to you. So here in S1 the command is show interface fast internet 0/20 switch port. If I execute this command, you can see here, say F0/20 is administered in trunk. That means in S1. In S1 I have manually configured or administered itself. That means manually configured it as trunk, and so it is operating as trunk. Okay, now when you take S2 here, I didn't configure any trunk in S2, so show interface fast internet 0/20 switch port. This command, let me show it to you here. Administrative mode is dynamic auto. It is part, or it is working as, or it is configured with dynamic, but it is operating as trunk, because the other end is configured as manual trunk. So this will also work as or operate as trunk. Any doubt? Any doubt, guys? Yes or no?
No.
Yes, sir.
Yes. Okay. I suppose you told you do not have any doubts. Okay. So now, shall we then move on? Okay. So this is the trunking. Okay. Now, so the points to remember is trunk will allow all the VLAN information, and again you can customize the trunk as well. Okay, now the next thing that we will study is called DTP. It's called DTP. So you can write the heading DTP, Dynamic Trunking Protocol. Dynamic Trunking Protocol, DTP. Okay, so in Dynamic Trunking Protocol, so let me tell you what is this Dynamic Trunking Protocol. So here you got S1 and here you got S2. Okay, now suppose you got, say, the previous figure here. Let me take the paint. Yes, this one. Okay. Now, how many VLANs we have got? 4 VLANs we have got. VLAN 1 is there, VLAN 100 is there, VLAN 200 is there, and VLAN 300 is there. Now, I told you that if at all it's a trunk link, suppose these are trunk links. Now, if you are sending something, suppose if you are sending VLAN 100, if you are sending some VLAN 100 information, then if you are sending a broadcast, then this broadcast will be sent to all the VLAN 100 interfaces, including it will be sent to through the trunk link also. Okay, it will be sent through the trunk link as well. Now, when it reaches S2, how S2 will understand this message is VLAN 100 message? If it only understands it as VLAN 100, then only it will be able to send to VLAN all the VLAN 100 interfaces, right? Now, how will, suppose again the same question, if VLAN 200 is broadcasting something, it will be sent to all the interfaces in VLAN 200, also through the trunk link. So when S2 receives it, he should understand this frame, it is a VLAN 200 message, right? Then only it will be able to pass it to all the VLAN 200 interfaces. Yes or no?
Yes.
Okay. So when you pass a frame through the trunk link, VLAN information will get added. Okay, when you pass the frames to the trunk link, VLAN information will get added. Suppose if it is VLAN 200, they will add it is VLAN 200. Then when S2 receives it, then he will read it, he will understand it is VLAN 200, then he will forward it to that respective interfaces. So the protocols which add the VLAN information while passing the frame through the trunk link, those protocols are called dynamic trunking protocols. So one more time, the protocols which add the VLAN information to the frame while it is passed through the trunk link, and that protocol is called dynamic trunking protocols. Clear? Now you got two protocols in DTP to study. The first one is called ISL, inter-switch link. Inter-switch link. Inter-switch link, or it's called ISL, dynamic trunking protocols. Okay. Feeling sleepy? Sure. Okay. Yes. So the second protocol, that is called .1Q. That's called .1Q, or it is also called IEEE 802.1Q. Okay. Now, the third one, it's not a protocol. Okay, it is not a protocol. It is called auto. It is called auto. It is not a protocol. Okay. Now, let me tell you about ISL and .1q. Okay. So, ISL or inter switch link. If you are making this dynamic trunking protocol as ISL here, and here also it is ISL, then what happens is that, say, when you are sending a frame, suppose when you are sending VLAN 200 frame, when you are sending VLAN 200 frames, say, while passing the frame through the trunk link, the ISL or this protocol will add an ISL header and an ISL trailer. Okay, they'll encapsulate the frame with an ISL header and an ISL trailer. And this ISL header, it consists of 26 bytes of information. It consists of how many bytes of information? 26 bytes of information. Okay, now in this 26 bytes of information, say 15 bit is reserved for VLAN ID. 15 bit is reserved for VLAN ID. So that means in that 15 bit they will mention it is VLAN 200, or it is VLAN 100, or it is VLAN 300, or it is VLAN 1. Getting it? So the ISL, what it will do is that it will encapsulate a header and trailer along with this frame. And this header, it is a 26 bytes value, of which 15 bit is reserved for VLAN ID. Clear? So this portion, this 15 bit portion says which VLAN it belongs to. So when S2 receives it, he is gonna check this. He is gonna read this value, this 15 bit value, and then he will understand which VLAN it belongs. Then it will send it to the respective VLAN interfaces. Clear? Any doubt?
Sorry, the 26 bits or 26 bytes?
26 bytes. Okay. This ISL header is 26 bytes and the VLAN ID is 15 bits. Okay. Yes. So that is the ISL. Now the next one. The next protocol is the .1q protocol. It is the .1q protocol. Now again, let me tell you one more thing. To make it participate in ISL, to make an interface, the trunk interface participate in ISL protocol, the command syntax is like this. You will go to the switch. You will go to the switch and you will mention, you will go to the trunk interface. Sorry. You will go to the trunk interface here. Interface FA0/20 suppose. Okay, the trunk interface. And you will mention the command like this: switch port trunk encapsulation ISL. This is the command. Unfortunately, the packet tracer won't support this command. Say the command to make it participate in, say, dynamic trunking protocol of ISL. Then this is the command. You will go to that, say, trunk interface, and you will mention switch port trunk encapsulation ISL. Okay. Now the next command or the next protocol. So the next protocol, which is called .1q protocol. Which is the protocol here? .1q protocol. Okay, now just give me a moment. The next protocol is .1q protocol. Now, if it's .1q protocol that is used, that is an IEEE protocol. That's an IEEE protocol. Now, if you are sending a frame, and suppose you are sending a VLAN 200 frame, what happens is that to this frame they will add a tag. They will add a tag, or they will add a small portion of tag here, and this process is called VLAN tagging process. Now this tag is of size 4 bytes in size. The tag is of size 4 bytes. of the 4 bytes, 12-bit portion. How many bit portion? 12-bit portion is assigned for VLAN ID. Any doubt? Yes or no? Okay, so if at all you are sending VLAN 200 information, then this frame will be tagged with a VLAN tag here, and the tag in this will contain 4 bytes of information, of which the 12-bit says it is VLAN 200. Okay, now if it is VLAN 300 information, instead of this VLAN ID you will have VLAN 300. Clear? So this is the .1Q protocol. Now to make this interface or make the trunk interface participate in, say, the .1Q protocol, the command is, we'll go to the trunk interface, and instead of this encapsulation ISL we'll mention .1Q, and this is the command that I told you to execute before executing the trunk. Right? Yes or no?
Both are command for trunk.
Both the commands, say these commands, switch port trunk encapsulation ISL and switch port trunk encapsulation .1Q. These are, say, to set the dynamic trunking protocols. The commands to set the dynamic trunking protocols.
Which one is better?
.1Q is better.
Why?
Because here, let me tell you why. So here I told you about ISL. ISL will be adding an ISL header and an ISL trailer. The ISL header, it consists of 26 bytes of information, right? So if the frame is 1500 bytes, suppose, in size, or 1512 bytes in size, again they will have to add, say, 26 bytes, and plus trailer contains 4 bytes of information, so 30 bytes need to be added. So that will again make the size bigger, and it will also, for the switches, it will be, say, like they need to process it, and if at all they can't process it, again that's an issue. Okay, but for .1Q they are only adding 4 bytes of information. They are only adding 4 bytes of information. So why do we need to add 30 bytes of information? We can just add only 4 bytes, right? So .1Q is better. Clear? Now you can see here as well, say, when I implemented the trunk here, say, let me show it to you. Show interfaces trunk. You can see the encapsulation is .1Q, 802.1Q encapsulation is there. Even they didn't use the ISL encapsulation, they only used 802.1Q. So ISL is Cisco proprietary and 802.1Q is IEEE's. Got it?
It's open standard.
Yes, it is open.
Most of the switches are having
802.1Q only. Okay.
nowadays.
Yes.
And your cross switch connection is always supported on
802.1Q only. And that is also one thing. So here, suppose if you got a Cisco switch, and suppose you got some other switches, say Juniper switch or some other switches, right? So if you want to make this as trunk interface, say ISL, if you give it, ISL is a Cisco proprietary and ISL works only in Cisco, right? So here you can't implement ISL here, you will implement .1Q. So here also they will support the .1Q, then it will work smoothly. Clear? So this is the .1Q protocol. Now I told you, yes.
Sir, another problem will be there. If the Juniper switch is new and Cisco switch is very old, the older one, then we cannot make the trunk because that switch only supports ISL. We have to replace that Cisco switch.
Yeah, I mean the older switches, Cisco older switches, right? Okay, because say previously they were having this the Cisco's one only, ISL. Now say they'll support the open standard as well, say the .1Q also, so you don't need to worry about that. Clear? Okay. Yes. Now that we'll go with the next thing, shall we? Now then I told you one more thing here. Yes, we'll come to that also. So I told you one more thing. Say we have got ISL, we got .1Q, and we got one more which is called, it's not a protocol but it is auto. So auto here, say suppose if you have implemented .1q here, okay, and here it is auto, then what happens is that this will automatically change to .1q. We don't have to do anything, it will automatically change to .1q. Clear? Now previously I told you, say you have to give, if you are making the trunk interface, you have to give the command like this: switch port trunk encapsulation .1q. The reason is that, say if at all the encapsulation mode is auto, if at all the encapsulation mode is auto, or if at all the dynamic trunking protocol DTP it is auto, then you will not be able to make this interface as manual trunk. To make interface as manual trunk, it should either have ISL configured or .1q configured. Clear? If it is auto, it will not, you cannot configure it as manual trunk. It will show an error like this. Say the encapsulation mode is auto, so trunk cannot be, manual trunk cannot be configured. Something like that it will show. Clear? So that's why I told you to make it as .1q, and then in the real switches. Okay, in some switches it will be auto here. In that case, say make it to .1q, then make it as trunk. Got it? Yes or no? Okay. So this is the ISL. Sorry, this is the dynamic trunking protocol. Not yet finished. One more thing. If you are using .1q, okay, suppose coming back to our topology, you are using .1q protocol. Here also you are using .1q protocol. Now, if you are sending the VLAN 300 information, it will get tagged. It will get tagged, and this tag says it is VLAN 300. Now, if VLAN 200 is sent, then instead of VLAN 300, it says VLAN 200. Now, instead of, if it is VLAN 100, then instead of 200 it will have VLAN 100. Okay, so here all the VLANs will be assigned, or all the VLANs information get, or I mean if you are sending a frame, all the frames will get tagged with the respective VLANs, but not for the VLAN 1. But not for the VLAN 1. So VLAN 1, that is called the native VLAN. VLAN 1 is called the native VLAN. And if you send the native VLAN information through the trunk link, the native VLAN information will not get tagged. The only VLAN which will not get tagged is the native VLAN. So if at all the switch 2 receives an untagged frame through the trunk interface, then it knows it is the native VLAN information. So then he can forward it to that respective VLAN interfaces. Clear? So there exists a concept called native VLAN, whose information or whose frames will not be tagged while passing through the .1q trunk link. Got it? Okay, so by default the native VLAN is VLAN 1. That means VLAN 1 frames will not be passed or will not be tagged while passing through the trunk link. So let me show it to you. Here you got, I told you by default it is native VLAN. Sorry, by default the native VLAN is VLAN 1. So here when I check it here, the command is, yes, you can see show interfaces trunk, native VLAN is VLAN 1. That means the VLAN 1 frames will not get tagged while passing through the trunk link. Everyone fine? Okay, the same thing here. Say show interfaces trunk. You can see native VLAN is VLAN 1. Okay, now the next thing, if you want to change the native VLAN, you can change it. To change the native VLAN, you will go to that respective interface. Suppose interface F0/20, interface FA0/20. Then we will change the native VLAN like this: switch port trunk native VLAN. If you want to give VLAN 200 as the native VLAN, you can give 200, or you can give 100 as the native VLAN, or you can give whichever VLAN you want, you can give that as the native VLAN by using this command: switch port trunk native VLAN 200 or native VLAN, suppose I'm changing it to 1. So it like that you can configure it. Clear? Any doubts? No? Fine? Okay. So this is the dynamic trunking protocol. Okay. Now, need a break or next portion? What do you say? Next portion. Okay. But I'll be taking a small break after this one. Okay. Now, so here, the next portion is called, it's a theoretical portion. Okay. Previously you had the say configuration, but now you do not have the config. Okay. It's called VTP. VLAN trunking protocol. VLAN trunking protocol. VLAN trunking protocol. DTP was dynamic trunking protocol. VTP is VLAN trunking protocol. Now, VLAN trunking protocol or VTP. So DTP, you know, DTP will mention or will add the VLAN IDs while passing a frame through the trunk link. Now, VTP is VLAN trunking protocol which will automatically create the VLANs. Suppose in S1 I have created the VLAN 100, VLAN 200, VLAN 300. Then in S2 also I had to go to that switch, then create the VLANs VLAN 100, 200, 300 like that. Right? So you have to manually create the VLANs in all the switches. That is again difficult. If you have 100 switches, you need to go to each and every switch, then configure VLAN 100, 200, 300, again 100, 200, 300, and then you can name it and all. But individually you need to do it in all the switches. So to make it easier, you got another protocol called VTP, VLAN trunking protocol, which helps you to configure the VLANs automatically or dynamically. That means if you configure VLAN 100, 200, 300 in S1, it will automatically get created in S2 or will be automatically get created in S3. Clear? Now let me tell you, so it will get automatically created, but you will have to have three conditions, or three conditions should be right. The first condition is that all the switches need to be in the same VTP domain. All the switches need to be in same VTP domain. That is the first condition. Okay, and the second condition is that all the switches should be connected using trunk link. All the switches should be connected using the trunk link. And the third one, all the VTP passwords, if at all it is configured, then the VTP password should be same for all the switches. VTP passwords should be same for all the switches. Clear? So these are the three conditions, and if these three conditions satisfies, then if you create a VLAN 100 in a switch, then in the other switch VLAN 100 will be automatically get created. Clear? Okay. Now when you do the VTP configuration, you can configure the switches in three modes. The first mode is called VTP server mode. You can configure a switch as VTP server mode. Okay, then you can configure the switch as VTP client mode. VTP client mode. Okay, and the third one, you can configure the switch as VTP transparent mode. Okay, so you can configure switch as VTP server mode, client mode, or transparent mode. Now, if it's a server mode, then let me tell you, so you can create VLANs, you can delete VLANs, you can edit VLANs. If it's in a client mode, if it's server mode, you can create, edit, and delete. If it's in a client mode, you cannot create, you cannot edit, or you cannot modify the VLANs. Okay, it's a transparent mode also, you can create, edit, and modify the VLANs. Clear? Okay, so this is the VTP, VLAN trunking protocol. Got it? Just give me a minute, guys. Yes. Okay. So now, guys, give me 5 minutes. I'll be back. Okay. We'll get back at 9. Sorry, it's not 21 p.m. It's 9:21 a.m. Okay. And after that, we'll go with 2 more topics, which are called InterVLAN communication. InterVLAN communication. Clear? Yes. So guys, you can also take a break. So shall we get back now? Okay, so now guys, sorry for the delay. Now we'll start. Okay, so now the topic that now you're gonna study is InterVLAN communication. So you can write the heading InterVLAN communication. InterVLAN communication. InterVLAN in the sense from one VLAN to another VLAN. Okay, suppose say previously I told you if you have VLAN 20 and VLAN 30 or VLAN 200 and VLAN 300, they will not communicate. Of course they will not communicate. So why? Because both are in different broadcast domains, network or different broadcast domains. Okay, so now again, I suppose yesterday for VLAN 200 and 300 and all, I might have given you some networks, right? Different networks I might have given you, right? So of course they are in different network or they are in different broadcast domain. For them to communicate with each other, what we need to have? We need a layer 3 device. We need a layer 3 device. Only if you have a layer 3 device, then you can make them communicate. Okay, so now let me tell you. So here, suppose you can say how many layer 3 device you know? Router is a layer 3 device, right? Of course, very good. So you can use a router for InterVLAN communication, or you can use L3 switch also for InterVLAN communication. So you can use, or you can do the InterVLAN using two devices, the router and then the L3 switch. If you use the router, then that is called a router on a stick. A router on a stick solution. Okay, now so using an L3 switch, that is called switch virtual interface. Switch virtual interface, both we will study. Okay, both are simple thing. Now so first let me teach you InterVLAN communication with router. InterVLAN communication with router. Okay, so that is called router on a stick, and let me now tell you about router on a stick. Suppose this is a switch, and this switch has got two VLANs. Okay, now that I'm taking us only a simple case. Okay, it has got two VLANs, suppose F0/1 and this F0/2, F0/1 in VLAN 10 and F0/2 in VLAN 20. Okay, now VLAN 10 machines have an IP, say suppose 172.16.10.0/24 network, and I've given an IP 10.10/24. Okay, now say this has got, say the VLAN 20 has got an IP network or the network 172.16.20.0/24, just giving some random IP range. Okay, and here let it be 20.10/24. Of course you know both are in different network, right? Yes or no? Okay, now so here, so previously if you have two networks, you used to connect it like this. Say you can have two switches, okay, and you can connect it to two interfaces of a router. So this can be 172.16.10.0/24 network, and this is 172.16.20.0/24 network. Both are connected to, say, different interface of a router. But now you can't connect it like that. You can connect it to only a single interface of a router. I mean, you will connect it to a single interface of a router like this, right? You can connect it like this. You can have a router, and the router, suppose gig 0/0/0 is connected, and suppose this is F0/24 or 23, whichever interface you want, you can connect it. Now, so in this case, what will you do? Now, previously, for these machines and all, you can set this IP address as this interface you can set as the gateway. For this machine also you can set this as the gateway, but here we do not have sufficient router interfaces, so to set for the gateway. right? We only got a single interface, and how many networks we got it? Two networks we got. So what we are going to do is we are going to split this physical interface into two sub interface. Virtually we are going to split it. Okay, virtually we are going to split this physical interface into two sub interface because we got two networks here or two VLANs here. So what I'm going to do is I'll create a sub interface. So here I'll be telling like this. I'll be creating a sub interface gig 0/0/0 dot say 10 or 20 or 30, any number you can give. Okay, so gig 0/0/0 dot, suppose I'm giving 100, any number you can give. So dot this a number, this is the sub interface number. Okay, then say what you will do is that you will mention the encapsulation is .1Q protocol, and then you will mention this needs to be participated in VLAN 10. Clear? Then you will give an IP of the range 172, this IP range. From this IP range you will give an IP. So the IP that I am gonna give here to this router's sub interfaces, suppose 172.16.10.1/24. Getting it, everyone?
Yes.
Naresh? Yes. Where did you go? You can ask the doubts. Yes. Which one? This one. Splitting it into sub interface, or which one you want me to? Sub interface. Simple. If you got a cake, right? If you got a piece of cake, and say suppose I have only Srikanth here. Only Srikanth is present today, and I got a piece of cake. Now I can give it to Srikanth, right? Suppose Srikanth and Kevin has come. Then what will I do? I'll split it into two, will give both of them. Now if I got say Srikanth, Kevin, and suppose Naresh also, then what will I do? I'll split it into three and give it to them. The same thing. So this interface is split into two parts or two sub interfaces. Split into two sub interfaces. It's split into virtually. Virtually it's split into two sub interface. Okay, because here how many VLANs we have got? We got two VLANs, VLAN 10 and 20. So we are split into two equal parts. That's it. Or two parts. Okay, and one part we have made it participate in VLAN 10. We have mentioned it should participate in VLAN 10. That's it. And then I have given an IP address. Got it? Okay.
If we have more than two interfaces,
You can give more than two in sub interface also. Okay, but that will be wastage, or waste in the sense unnecessarily we don't want to create the say configurations and all, right? Okay. Now say again you can give another sub interface gig 0/0/0 dot, suppose I'm giving dot 200. Then I'll mention the encapsulation is .1Q, that's the encapsulation, the same thing here, and then I'll mention it needs to participate in VLAN 20. Then I'll be giving the IP range of VLAN 20. So the IP, let it be say 172.16.20.1/24. Let that be the IP. Okay, then what I'm going to do is that for this computer, the gateway address, what will be the gateway? The gateway address will be the IP address of this router's interface. Okay, so here the IP address is 172.16.10.1. Clear? Okay, now so here the gateway address, what will be the gateway? The gateway address will be the concerned IP address of the router, the sub interface. So 172.16.20.1. done. And the final thing, the switch interface which is connected to the router. The switch interface which is connected to the router. This interface will be made as the trunk interface. This interface will be made as the trunk interface. Done, guys. Then this is the InterVLAN communication. Okay, the concept, say the configurations will do it, and then I'll be telling you the packet flow also. Okay, shall we do it? So now let me take the packet tracer. Let me take a switch here and do the pre-configs first. Okay. Okay, pre-config in the sense I got two machines, two computers, and of course I need to make them participate in different VLANs and give the computers an IP address as well. So here we'll go to the switch, so F0/1 and 2, VLAN 10 and 20. Okay, so VLAN 10, 20, okay, VLAN 20. Then what you're going to do is you'll go to interface FA0/1, where you will mention the command switch port mode access switch port. You know this command yesterday, I suppose you might have done the homework, right? So switch port access VLAN, yes, 10. Okay, yes, and interface FA0/2. Then you will go to that interface, mention the switch port mode access and switch port access VLAN 20. Okay, so then when you check do show VLAN brief, you can see VLAN 10, yes, F0/1 is in VLAN 10 and F0/2 is in VLAN 20. Clear? Okay, now that what you're gonna do is, now you will connect it to a router. So again, one more thing to do, the pre-config, the one more thing to do is the IP address. You need to give the IP address to the computers. So here the IP address here is say 172.16.10. I suppose it was 10 that for the computer. Now /24, so 255.255.255.0. and of course if you want you can give the gateway address now itself, which is 172.16.10.1. okay, yes, the same thing, we'll go to this one and we'll mention it here as well, say 172.16.20. yes, 10 is the computer's IP, and 255.255.255.0 and 172.16.21.20.1 is the gateway IP. Clear? Okay, so these are the pre-configs. Now what you're going to do is that you'll have a router, you'll keep a router here. You can keep a router. You can keep a router and you can connect it. Oops, sorry. So you will connect it. Suppose routers gig 0/0/0 to, so which interface that I've given it here, F0/24. okay, so F0/24 of the switch. Now what I'm going to do is, so now I'll create a sub interface. Now while creating the sub interface, one thing you have to make sure is that this is the main interface, the physical interface. This physical interface should be in up bar up state. It should be in up bar up state. That means it should be up. So we will, if at all it is down, we will make it as up. And if at all it is having an IP address, we will give no IP address also, because the main interface should not have an IP address. Clear? So now you will go to the router. You will first make sure do show IP interface brief. You can see gig 0/0/0 does not have an IP address. If at all it is having an IP address, you will go to that interface, you will give no IP address. Then you will again, so this is administratively down, so to make it as up, what you're going to do is you'll go to that interface gig 0/0/0, then you're going to make it up by giving the command no shutdown. Clear? Then you will create the sub interface. To create the sub interface, simple thing only, interface gig 0/0/0 is the usual command. Now we are going to create the 0/0/0.100 here. So what you're going to do, you're going to mention .100. That's it. So what happens is that do show IP interface brief. You can see a new sub interface has been created. A new sub interface has been created. Then you will mention, so here you can see the prompt has moved into the sub if. It is not the interface now, it has moved into the sub interface. Okay, then you will give the command like this. You will mention the .1q and 10. So the encapsulation is .1q. You will mention it like that. Encapsulation is .1q. Okay, encapsulation dot 1q, and the VLAN ID is VLAN 10. The VLAN which it should participate is VLAN 10. Okay, yes. Then you will give the IP address. What is the IP that you will be giving? 172.16.10.1. So 172.16.10.1 255.255.255.0. That's it. Okay. Yes. The same thing we'll do it in the next sub interface also. So you will mention interface gigabit 0/0/0/0.200. Then this 200 and also it came up. Then you will give the encapsulation dot 1q, and it should participate in VLAN 20. Then you will give the IP address, which is 172.16.20.1 255.255.255.0. That's it, done. And the last and the final thing that I told you, we'll go to the switch interface F0/24 and make it as trunk. So we'll go to the switch F0/24 interface F0/24, say switch port mode trunk, done. So do show interface trunk. You can see F0/24 is trunk now. So what happens is that if this computer is trying to communicate, this first computer is trying to communicate to a second computer, so both are in different networks. So what happens is that it will be sent to the packet will be sent to the gateway first. So it is sent to the gateway, where the router sub interface will receive it, and the router will process this packet, and the router will check the routing table and all. It will come to know that the destination IP is connected via gig 0/0/0.200. So then this will be passed through this gig 0/0/0.200, and the switch will receive it and will pass it to the second machine. So it is not the packet will be going directly from the computer 1 to computer 2, but the packet will go to the router, then the router will send it to this machine 2. Clear? Any doubts? Okay, so I suppose now we can ping it. Now when you ping it, the command is 172.16.20.10. We'll see what happens here. We are getting the reply. So you can see you are getting the reply here. Yes, you are getting the reply from 172.16.20.10. And again, let me just tell you. So here, say trace route or trace RT is the command to view the path. So 172.16.20.10. Okay, I suppose that we are given 20.10 only, right? Yes. Then you can give the path. So you can see the first, it is going to 172.16.10.1, which is that interface, is the router's interface. So the packet is first sent to the router, then only it will be sent to the computer.
This will also decrease the bandwidth of the interface?
Not really. Say if you have multiple machines and all, there are chances. Okay, because through only a single link you are passing. If you have multiple, say, machines communicating with, say, the VLANs, then the bandwidth will be utilized. If you have multiple, many machines, okay, or else it will be no issues. If you do not have that much traffic, means you don't have any issues. Okay, yes. Now this is the route runner stick. Route runner stick. Okay, then the next is, so this is how you will do it for the router, or this is how you will, say, have the inter-VLAN communication by using a router. Okay, today you can do these things. Okay, tomorrow I'll give you a task. We don't have any pending tasks. Do we have any? No. So in that case, tomorrow I'll be giving the task for these things. Okay, now shall we study the next one? Inter-VLAN using, yes, L3 switch, which is, yes, switch virtual interface. So you can write the heading switch virtual interface. So what I'm going to do is let these things be the same. These things in the sense, okay, the computers, the IP address and everything will be the same, and only the thing is that I'm gonna implement a switch here, layer 3 switch. Suppose this is the layer 3 switch and this is the symbol of the layer 3 switch, multi-layer switch. Okay, so now I'll be connecting this to F0/1 and this to F0/2, and let me do the pre-configs also. Pre-config in the sense, so F0/1 needs to be in VLAN 10 and F0/2 needs to be in VLAN 20. Okay, so now I'll go to the interface FA0/1 switch port mode access, switch port access VLAN 10, then okay, so you can directly create the VLAN. So you can instead of creating the VLAN, you can directly assign this interface with the VLAN, thereby it will automatically create the VLAN. Clear? Like that also you can do it. Okay, so you can avoid a step like this, the previous. So this is okay. Here you can see access VLAN does not access, creating VLAN 20. Now then what you're gonna do is, say here, so now this is assigned to VLAN 10 and this is assigned to VLAN 20. Then what we will do is that in this switch, so then I might have taught you that the L3 switch, you can give multiple IP address to the L3 switch. In L2 switch also you can give multiple IP address to L2 switch, but only the latest IP will be active. Only the latest IP will be active for L2 switch. For L3 switch you can give multiple IPs to multiple VLANs. Multiple IPs to multiple VLANs. So let me tell you how you can give the IP to the VLANs. So what you're going to do is, you will give IP to VLAN 10. Suppose the IP is 172.16.10.1/24. Okay, then here you will give IP to VLAN 20, 172.16.20.1/24, and for this computer the gateway will be 172.16.10.1, and for this computer the gateway will be 172.16.20.1. Getting it, guys? So what happens is that when this computer is trying to communicate to this computer which is in another network, the packet will be sent to this gateway address. The packet will be sent to this gateway address, and the gateway address, it is the IP address of the switch, right? It is the IP address of the switch. And what it will do is that, say this is a multi-layer switch, and we will enable the L3 features of the switch. We'll do what? We'll enable the L3 features of the switch, so that the switch will check the packet level. The switch will check the packet level. So it will check the packet, the source IP, he'll understand the source IP is this, and the destination IP is 172.16.20.1. And as we have enabled the L3 service, then this multi-layer switch will have a routing table. And from this routing table, he'll come to know that 172.16.20.network is connected to VLAN 20 interface. And then it will forward to all the interface participating to VLAN 20, including this interface, and thereby the message has reached this machine. Got it? The same thing with the reply. So when the reply is sent, say again, say it is received via F0/2, which is in VLAN 20. Then say the switch, so now the switch will act as a route role. So he will check the packet, he'll come to know the destination is 172.16. Then he will check the routing table, he'll come to know that it is connected to VLAN 10, and he will send it to all the VLAN 10 interfaces. Clear? Any doubt? Anything, guys? Kevin? Yeah, Naresh, Srikanth, Satish. Okay, now so here I'm gonna give the IP address to VLAN 10. I'll go to the switch and I'll give the IP address like this, interface VLAN 10. Then I'll give the IP address is 172.16.10.1 255.255.255.0, and it is already up, so we don't need to give up no shutdown. Okay, if it is down, then you can give no shutdown. Then we will give IP address to the next VLAN, interface VLAN 20. Then we'll give the IP address. The IP address is say 172.16.20.1. Done. Now I told you we will enable the layer 3 features. Okay, if you enable the layer 3, to enable the layer 3 features, the command is IP routing. IP routing. This is the command to enable the layer 3 features. Now that you are enabled the layer 3 features, you can, if at all you want, you can take a look at the routing table. The command is do show IP route. Do show IP route, and you can see, say VLAN 10, this is the network, and VLAN 20, this is the network. Clear? Okay. Now if you send the packet, ping to the other one. Okay. Yes, you can see you are getting the reply. So this is how you are getting the reply. Now if you use the trace RT, you can see it is first going to 172.16.10.1, which is that one. It is the interface of, yes, switch 1. I mean this switch, this interface IP. So again this happens, what happens is that it will be sent to the gateway, which is the VLAN interface of the switch, and from the switch it will be sent to the machine, and the switch will be processing the packets now, not the frames. He'll be processing the packets. He'll be processing it in L3, and that is why I told we need multi-layer switches or L3 switches, so that it will be processed, the packets will be processed in L3. Got it? Any doubts, guys? Kevin? Oh, okay. Online guys, any doubts?
No, sir.
Okay.
layer 3 switch है.
Yeah, exactly. Here we must have layer 3 switch. Then only they will process. They can process in L3.
In network.
Yeah, of course. There's also layer 3. The down one. Here down one, and there the up one. Okay. So here we have L3 switches. Say I suppose it is 35. Don't remember which model. 3550. I suppose. 3550 series switches. Or I suppose it is 3550 or 3650 or 3560. Which one it is, I don't remember. Okay, these are the L3 layer switches. So these are like the switches we have it here in NH. These are like almost the end of the life. Okay, end of support and end of the life, because see, this is only for the studying purpose, right? So if we have these, the older device also no issues. It's just for only studying purpose that we are using it.
So it is not using in industry.
You know, now I suppose that these are like not used in industries, but still you can see in some places they still have these things, these older ones.
But we need this
Maybe.
information about this,
Yes, of course.
knowledge about this.
Yes. Got it. Okay. So this is the InterVLAN communication. I hope you will be doing these things. Tomorrow I'll be giving you topology. Just remind me. Okay. Just remind me to give the homework topology and all. And now, say the switching is almost over. We have two more small portions. The first portion is called port security. Okay. And the second is called ether channel. Then the switching is over. Okay. And if the switching is over, then we'll be completing within 10 days. We'll be completing.
What about CST, PVST, and
Yeah, of course. Remind me that also. Okay. PVST, that's just a 10 minutes. I'll be explaining it theoretically. Okay. PVST, CST, say MST. That also I'll explain it. Okay. Yes. So then, shall we wind up the class for today?
Yes.
Okay. So again, let me stop recording.